Okay, let's go. So now we're talking about, quiet please, quiet, right, attention. This is about, it's called systems of equations, right? I expect that our test will be on the 9th, so let's see, today is the 30th. I think that makes that the Thursday of next week, if everything goes, and quizzes again are going to be like TBD, because we'll probably have like, we could have 1 or 2 this week, who knows, won't be today or tomorrow. Okay, so systems of equations. So systems of equations means you got more than one equation, right? More than one equation with more than one variable. That's what a system is. And this is just an example of how we use systems of equations. We will get to solving things like this. But for example, 15 adults and children attend a magic show that costs $7 per adult and $5 per child. They spend $105. How many adults and how many children attended the show? So right away, there's 2 things you don't know. You don't know the number of adults, you don't know the number of children. So this means you can't just have one equation to solve for it. That's why we need a system of 2 equations to solve for 2 variables. That's generally the way it goes. In this case, right, we could say that since a total of 15 attended, that A plus C, the number of adults plus the number of children, was 15. And since it costs $7 for an adult and $5 for a child, then 7A plus 5C was the 105 they talked about. So we have to use the information to set up this system, and then what we're going to do now is just learn, okay, well then how do we solve something like that for the values of A and C, right? So, you know, you can solve, generally speaking, you can solve, I think I've got a slide on this. Okay, we'll get to it in a second. So for example, if you got 2 equations and 2 variables, that would be like these 2 equations. That means you could graph it in the coordinate plane, right? Each one of those is linear. It's y equals mx plus b, so we should be able to graph it, right? So let's graph this system just to show, right? And let's see, what's the first point that we graph? So we graph the -3, right? And then how do we use the slope of 2 to go to another point on the graph? So go up 2, right 1, right? And then we draw a line that goes through those 2. Let me draw it, make it blue. So that'll be something like that. Okay, then let's do the other one. I'll make this one red. Okay, y-intercept is +2, so go up 2. The slope is -3, so that means -3 over +1, right? And then I'm going to draw the line. This time I'll make it red. So that's what the graph of a system looks like. And the solution to the system is the set of points that solve both. Okay, well, where do you look on that graph to find a point that solves both lines? Where they intersect, right? So the solution, in this case, because it's 2 equations and 2 variables, the solution can be represented by graphs, and if they intersect, that intersection is what we call the solution to the system. Right? That's the solution, wherever they cross, because that means that one point is on both lines. Okay, so for the solution to a system is a set of points that satisfy all, in this case, both equations. And for 2 equations with 2 variables, it is the intersection point of the graphs. Now, we're familiar with those. Those are the same kind of graphs we've been drawing up till now. Now, systems can be bigger than that. They don't have to be 2 equations and 2 variables, right? They could be 3 equations and 3 variables, or 4 equations and 4 variables. I mean, ultimately, you need the same number of equations as you've got variables to solve for, and then you can find the solution. But in this class, all we do is 2 equations and 2 variables. You know, again, my background being in meteorology, when you model the atmosphere with math equations, it's actually 7 equations and 7 variables, right? The variables are pressure, temperature, wind, and wind counts 3 components. There's 3 components of the wind. There's the east-west component, there's the north-south component, and there's the vertical up and down component. So that's 3. So we're up to 5. Relative humidity, and then a variable for condensation, which allows for moisture to come out of the air, right? So there's your seven variables. So we need 7 equations. Okay, quiet, please. Okay, now, if they were linear equations, then when we solved them, we would just get this one point, and that would be the answer. And we know the weather's more complicated than that. But the equations are not linear. They're what we would call partial differential equations. And they have an independent variable of time. So they're all going forward in time. That's why you watch the weather guy on TV, and he's giving you some model forecast. That's what it is. And they're probably a little more complicated than the 7 equations and 7 variables, but those are what we call the primitive equations in meteorology. So that's what I studied when I was in school. Okay, so there's 3 possibilities. If we're talking about systems that have 2 variables, 2 equations, that means we can graph them in the coordinate plane on an x and a y axis, then there's 3 possibilities, right? One is they intersect at a point. Something like that, right? One unique solution. I thought I was on the line drawer. Okay. Now, what would it have to look like for the lines to not share any points? Well, they'd have to be parallel, right? So they'd have to be something like that. That would be a no solution, and we'll get those as solutions. Sometimes if you got parallel lines, it'll come up as that kind of a false thing like 0 equals 2, and you'll say, okay, well that means there's no solutions. Okay, the last possibility is, what if the 2 equations, they might look a little bit different, but it's actually the same line. You know, so it looks something like this. Now I will draw the line. Right, so here's one line, and the other one, once you solve for y and you do everything like that, it actually is like right on top of that first line. I'm drawing it right next to, but if you can imagine one line being on top of the other, how many points do they share? Infinitely many, right? So that's like no unique solution. Really, what we spend like almost all of our time on is this one right here. How do you find the solution when there is just one point? That's the solution. Okay. So systems of equations. So here's the different methods that we're going to have for solving a system of equations. First one is called graphing. And although we just showed how graphing can lead to a solution, we're actually going to do that last. Because when we do this, understanding our limitations in solving by graphing, because it depends on you being able to draw a good graph, well, we're going to let the calculator do that part, right? But first we're going to do, there's 2 algebraic methods for solving a system. One is called substitution, and one is called elimination. So today, I don't remember how far I went with this. Solve by graphing. So just to show the concept, if we're going to solve these by graphing, what do I need to do to these equations first? Solve for y, right? You need them solved for y, because we graph things in slope-intercept form. So this one, what will this one look like if it's solved for y? Y equals positive x minus 2, right? If I add x to both sides, if it's negative on the left, it's positive on the right, okay? How about the next one? What would be the first step of solving for y here? Subtract 2x, subtract 2x, right? Now I've got negative y equals negative 2x plus 6. Is that solved for y? What do I have to do to finish that off? Multiply or divide by negative 1, which will flip the signs of every term. So now it becomes 2x minus 6, right? So that's what we have to graph. I think no. So now let me graph. So let's see, a plus 6 and a minus 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if it's plus 6, and then it's a slope of negative 2, that means down 2, right 1. Okay. The next one. No, I'm doing this one here. Oh, you're right. I was looking at the wrong thing. I was looking in the wrong place. Sorry. Okay. I got to start this over. Okay, so that was actually minus 6, 4, 5, 6, and a slope of positive 2. So it should look something like that. Okay, and the other one is x minus 2, so that'll be slope is, or sorry, the y-intercept is negative 2, the slope is 1. So go up 1, right 1, and draw a line. Okay, let's see, what that would be about 2, 3, 4. So what do you estimate to be that point right there? 4, 1. Okay. So now how can I confirm if that actually is the solution? Plug it into the two equations, right? Go to the original equations just in case you actually solve them incorrectly. So if I put in a 4 here, it'd be negative 4 plus 1 equals negative 3. So that's not quite right. What if I put it in the other one? I'm going to get 2 times 4 is 8, minus 1 is 7. So you could see my graph wasn't accurate enough, so I'm not quite right. Can anybody guess what I needed to do to make that correct? I think if the y was 2, then it would have satisfied both of those. Right, so if I would have gone negative 4 plus 2, I would have got the negative 2. Or 2x, 8 minus 2, I would have gotten the 6. So probably that's not correct. That's why you got to check. Right, 4, 2. So I mean, that's why the best, with graphing, you're not going to always be exactly right. You're going to plug it in and maybe you'll get it and maybe you won't. Which we're doing now just for the concept of it. You know, that's how it works. In the end, we'll let the calculator do that and we'll get it exact every time. So try to do this one. Try to sketch graphs, solve for y, sketch graphs, and see if you could figure out what is the intersection point.
That would be positive 2. Because that would be a negative over a negative. You can also go down and right. That's negative 2. So I bet you that's How would you want to never mind. Man, that's creepy. So I bet you.
Yeah, it's so much quieter than actually tired.
Remember how that was the right one? So I bet you that's where if you plug those in, my birthday's in July. This is too small.
Why? Okay, quiet please. So it should have been, these should have been the two equations when you solve for y, right? Y equals x minus 7, y equals negative 1/4 x minus 2. Right, those should have been the two equations. Okay, so you graph them. Minus 7 and slope of 1, up 1, right 1. Draw a line.
So these are these the answers? You just
What's that?
graph the line.
Okay, well, you graph both the lines and you look for the intersection point. Yeah. Yes. Okay, quiet please. So if it asks for a solution, you've got to give the solution an XY point, right? If it just, sometimes like on the SOL, there'll be a graph that'll show the two lines and it'll ask you to go with the cursor and just like indicate where it's at. So they're trying to get at, do you understand that it's the intersection point? They don't actually ask you for the intersection point. Right? So the second line, quiet please, quiet. The second line has a y-intercept of -2 and a slope of -1/4. Down 1, right 4. Down 1, right 4. Draw the line. Okay, so now, what do we estimate to be that intersection point? About 4, -3. Okay, let's try and check that out. If I put in a 4, I'll get -4 minus 3 is -7. That's correct. How about the other one? 4 plus 4 times -3 is 4 minus 12, which is -8, which is good. So actually that is the exact right point. Okay, so now we're moving on. Like I say, we'll get back to graphing. When we really want to know the point exactly, and we're going to do it by graphing, we're going to do it with the calculator. So it's not going to depend on how well we can draw a line. It will depend on us sometimes solving for y to put the right equation inside. Right? So these are the steps. Right? This is getting more complicated. If I was you, I'd be writing this down. Right? You have two equations and two variables. First step is solve one of the equations for one of the variables. Right? And you get to pick. Right? Sometimes there's like an obvious choice, but in the end you get to pick, and there's really no wrong answers here. You could pick any one of the four, right? Either of the two variables and either of the two equations and still be right. So we'll solve one equation for one variable, and then we'll substitute for that variable in the other equation. That'll leave us only one equation with one variable, and that's something we can solve using the algebra we know already. Right? So that'll give us, when we get done with that, we'll know the value of one variable. Then we'll have to find the value of the other variable. So we'll have to go back and solve for the other variable.
What was that? Sound like a hyena. Michael Jackson. Not you. Hyenas do not sound like that. You might even like that. Michael, shut up. I had to be quiet. Stop talking.
Okay, we done?
Yeah.
Hurry up. If you didn't start yet, then why not, John? We're not waiting for forever, right? No, it's up to you, right? When you start showing how you know how to do this, then this is what I'm expecting to see.
I'm not a very fast writer. Oh my god.
Okay, so let's show those steps in action. So first step, what did it say? Solve one equation for one variable, right? Now, you could do any one you want, but there's one that's kind of supposed to be the obvious choice here. Which variable would it look like it's easiest to solve for? The first x, right? What is it that makes that one the easiest to solve for? There's no coefficient. It's got 1 as a coefficient, which means if I solve for any of those three, the last step I would have to divide by a number that makes fractions, and that makes things harder. So if you've got a choice, choose the x because it's 1x. Right? So first step, I'm going to solve for that. What does that look like once I solve it for x? X equals. I'm going to show this. So here we go. X minus 2y equals -6. How do I solve that for x? I have to add 2y, right? I'm trying to isolate the x. Okay, so now I have x equals 2y minus 6. Okay, that's the first step, right? What does the second step say?
Substitute for that variable.
Right, substitute for that variable in the other equation. So that means in this equation here, in the place of x right there, we're going to put 2y minus 6. Right, so it'll look like this. 4 times 2y minus 6 plus 6y equals 4. Right, so this was the first step. This is the second step. At the end of the second step, what did it say to do? Solve, right? We just reduced our system to one equation with one variable, and we can solve this using just the basic algebra, right? What would be the first step to solve this? Distribute the 4, right? So that should look like 8y minus 24 plus 6y equals 4. Okay, then what? Then what? Combine like terms on the same side. Remember, quiet please. The last thing you want to do is like subtract 6y and 6y. What would be wrong with that?
We're both on the same side.
They're both on the same side,
Okay,
right?
add like
So this is the place where you combine the variable terms on the same side. So that's going to be 14y minus 24 equals 4. Okay, now it's 2 steps to solve that for y. What are the 2 steps?
minus 24.
Add 24. $14y equals, okay, quiet please. 14y is 28. Last step, divide by 14, right? So y equals 2. Okay, that was the end of step 2. What does step 3 say to do? Okay, so with substitution, define the second variable, you've got the perfect place to go. That equation that you solve for x in the first, plug it in there. Plug in y equals 2 there. Solve for x.
X equals negative. I did this on my own school, bro. This is, I hate this.
You do the same thing.
Yes, I do. I do. And it takes too much time.
Then you know, 2 times 2 y.
Okay? So what is the solution to this system of equations? Remember, it's a point. Sid. Yeah, it's the x coordinate, comma, the y coordinate. That's the solution. So without graphing it, we could tell you that it would have crossed at negative 2, 2. Well, get used to it. Just gets more. Yeah, I mean, it's 3 steps. Right? The first step, solve one equation for one variable. Second step, substitute for that variable in the other equation. Solve. Third step, substitute that answer into what you get at the end of step 1. I mean, there you see, why do they call this method substitution? Because we're substituting. Okay, let's try again. Okay? So what is the... Quiet, please. What does it say again? First step would be... Okay, solve one equation for one variable. What do you notice about this system? One of them is already solved. So actually that's even easier, right? So we'll get to the point where you're given a system and you're not told how to solve it. You could do substitution or elimination. And in this case, you would say, well, I'm going to do substitution because one of them is already solved for y. They've already done the first step. Okay, so move on to the second step. What should I do with that y equals 3x plus 2? Right, I got to take this 3x plus 2 and put it in the place of y there. So it'll look like x plus 2, parentheses, 3x plus 2 equals 11. Right? And by doing that, I just changed it now. I only have one equation with one variable, and that I can solve using basic algebra. Okay, what should I do as the first step? Distribute again. X plus 6x plus 4 equals 11. Next step. Combine like terms, right? 7x plus 4 equals 11. Subtract 4.
I'm just thinking about something else.
Okay, quiet. Pay attention this way. Connor. Okay. Last step.
Divided by 7x.
No, just 7, not x.
7.
X equals 1.
That's a neck.
Okay. Now, how am I going to find y now? I know the x. How do I find the y?
Plug x in for the...
In the first equation, the one that was already solved for y, that's where you plug it in. So now we'll get like this, right? We'll get y equals 3 times 1 plus 2. Y equals 3 plus 2, so y equals 5. Okay, so here's 1 comma 5. Okay, so there's got to be a you try in here. All right, you try. Okay, so this one of quiet, please. Quiet. Kaylee. Right? One of them was already solved for y, so I didn't have to do that part. Right? What did I do next? I take that 2x plus 5 and I put it in the place of y there. So it's 3x plus 2x plus 5 equals 10. And I've seen some of you as going around that you have that like in parentheses, which is okay. It's just that in the end, the parentheses aren't doing anything for you there. And maybe it's stopping you from combining like terms. So 3x plus 2x, 5x. Right? Subtract 5. Divide by 5. Right? Okay, now how am I going to find the y? I got to go back to that solve for y equation right up here, right? And make it y equals 2 times 1 plus 5, which is 7. So what is the point? 1 comma 7. You should put it in parentheses like it's a point, right?
Mr. Callahan.
See, yes.
Oh wait, never mind. Wait, yeah. I filled that one in. I don't know why, but I still got the right answer. I filled the one in for the second equation.
In the second equation?
Yeah.
It'll work. It'll work in either one. It's just that in substitution, you've got a place to go that's actually easiest because you already solved it for that first variable. You know what I mean? But if you do the other one, it should work. Okay, now try this one. This one does not have one that's solved for y. I saw a couple that had the right answer. Which equation should I have solved for which variable? The first equation for y is probably the best choice. Okay, what does that look like when it's solved for y? Right, negative 3x minus 7. Okay, what's the second step? Second step. Substitute for that variable in the other equation, right? So that'll look like this. Negative 2x plus 4 times negative 3x minus 7 equals 0. All right, so now we've got one equation with one variable, so we should be able to finish it off. Right, it'll be negative 2x minus 12x minus 28 equals 0. Right, combine like terms. Negative 14x minus 28 equals 0. Right, add 28. Negative 14x equals positive 28. Divide by negative 14. So x equals negative 2. Okay, now what do I do to find the y? I take that in there, right? I take it to the equation that we solved for y in the first step. That's the easiest place. So that'll give me y equals negative 3 times negative 2 minus 7 right? Y equals positive 6 minus 7. Right, so that is negative 2, negative 1. How many got negative 2, negative 1? Handful? Handful? Okay.
When I resolved it, I got it.
So tomorrow we're going to continue with the same thing, with rule 7-2. Substitution. And that is the homework. How many? It's only 6 problems.